What is artificial intelligence, or AI? How does it really work under the covers? AI humanoid robots are being built right now to work in factories and warehouses to do the same types of jobs that people do. Artificial intelligence, or AI, is driving driverless taxis in major cities right now. And if you don't work in a warehouse or a factory, if you don't drive a taxi or an Uber or Lyft or some other car service, don't get too comfortable. Because in Colombia, South America, an AI-powered robot did a complete dental procedure end-to-end with no human intervention. The dentist left the room and the robot put a crown on a volunteer patient's tooth in 15 minutes compared to the 2 hours it normally takes a human dentist to do the same thing. AI robo-advisors are already advising investors on what investments to make. So AI will be impacting your job either now or in the future. Actually, AI is impacting your life right now. AI chooses every single video that you get presented to see if you want to watch it or not, including this video. AI chooses every Facebook post that you see, every TikTok you're presented, every Instagram, everything on all the major social sites. The things that you're presented are powered by AI. AI determines every product recommendation that you're presented with on Amazon or other major shopping sites. It's built into your phone. It knows what you look like. It knows who you are. It knows what you do. It knows what your face looks like. It knows what your family's faces look like. AI even determines the search results you're presented with when you search on Google or Yahoo or any other major search engine. And if you're applying for a job at a large company, AI even screens your resume before you ever get to talk to a human being. So how does AI work and how does it do all these things? What are its benefits and dangers and where is it going? Where is AI going, for good or for bad? I've been a product manager for artificial intelligence and other advanced technologies in major technology companies for over 20 years. And in this video series, I'll explain to you what AI is, how it works, some good and bad uses that are happening right now, benefits and dangers, and where it's going in the future. I'm also a visiting professor at Now Theological College. So for Christians and non-Christians, I'll explain some things without conspiracy theories about how AI is likely to be used in the last days before Jesus Christ returns. I help you think biblically balanced about doctrine, world events, and societal issues like this one. My name is Robert. I'm a pastor and a technologist. Let's get right into it. When I was a product management leader for artificial intelligence in a major software company, we did big projects. We did artificial intelligence projects for power plants, for oil fields, and for fleets of jet engines. One day, the leader of our AI research came and told us about a robot dog. And this dog had been programmed with artificial intelligence techniques to teach itself how to walk. Now, in standard programming, ordinary programming, it's an arduous, difficult, time-consuming thing because you have to figure out what all four of the feet of the dog will do, what the head will do, what every part of the dog's body, the robot's body, will do. You have to figure out how you think everything is supposed to move. And then if something goes wrong, you have to go and correct your code and enhance your code. And it takes iterations. It's a very, very time-consuming and arduous task. This dog actually learned how to walk much, much faster than it would have if it had been programmed with standard programming techniques using these AI programming techniques. So it taught itself how to walk very quickly. And then it taught itself how to play soccer. And playing soccer wasn't even something that it was programmed to do. How on earth did it do that? Daniel 12:4 says that at the time of the end, many shall go to and fro, and knowledge shall increase. God gave Daniel this prophecy in 600 BC, 2,600 years ago. And with AI, knowledge has increased at a pace that was absolutely unimaginable to Daniel or to anyone else during his time. AI has changed the world, and it's going to change the world more in ways that we can't even comprehend right now. So how did this robot dog teach itself to do something so complex that it wasn't even programmed to do? The answer to how this dog could make a huge leap and do something so complex is actually a combination of things, because AI is not just one thing. We're used to thinking of AI typically as this big monolithic thing that's out there somewhere, and this big thing called AI is doing all of these sorts of stuff. It's actually not that. There are thousands of different AI programs written by thousands of different people, hundreds of companies. They do a myriad of different things, specialized tasks. There are different degrees of intelligence to them. AI is a wide range of programming technologies. That said, this wide range of things that AI does fall into basically 6 broad areas. And these 6 broad areas can be divided really into 2 broad groups. The first group of things around AI is what AI does. And there are 3 broad things that AI does. The one that we're most familiar with, most of us, even though we may not know the name, is natural language processing. And that is when a computer can hear from a human and we can speak in our own natural language to the computer can understand what we do, the AI program actually can understand what we're saying, and then it can respond to us. So this is something like Apple Siri, Google Assistant, Amazon Alexa, and those types of programs use natural language processing. You could ask Siri, what is 4 plus 5? Or show me the nearest food stores around me. And then Siri will be able to do that. Or you can ask Amazon Alexa, Alexa, turn my lights off in the living room or in the bedroom, or turn them on, or turn my TV set on. And then Alexa will be able to do that. Another one is programs like ChatGPT, where you can type something in, you can say, ChatGPT, summarize this book of the Bible for me, and then it'll give you a summary of the Bible. Or you can even ask it to design thumbnails for your videos, and it'll give you a verbal description of what a thumbnail ought to look like. And you can do that in natural language, in own language. Another one is when you call a bank or a store, and they will say, well, tell me in your language what you would like, and I will try to help you. And if I can't help you, then I'll turn you over to a human being. We can speak in our own natural voices. We don't need to know specific computer commands in order to get something done. And this happens with search engines too. And that's called natural language processing. A second big area is computer vision. And this has to do with things like facial recognition for security cameras, or security camera processing of images, or being able to detect an image of whether it's a dog or a cat or a mouse or a flower. It's something also that's used in self-driving cars, where the cameras around the car will look at different things and detect objects and be able to see that this car is coming close, or there's a gap here so I can change lanes. So all of that goes into computer vision. Another area of AI is the most powerful and impactful. It's also the most exciting and the most scary, and that is called cognitive computing. Cognitive computing is when AI is designed and developed to make decisions similar to the way that people make decisions. Cognitive AI is designed to analyze evidence the way humans do, and to come up with the most accurate conclusions and accurate insights that are possible from the data that it's given. It can often match and even exceed humans in that capacity. Some of the uses of cognitive computing have been truly remarkable. Google DeepMind, for instance, generated a protein binder for a protein called VEGF-A. And VEGF-A is a protein that figures into the development of new blood cells. And so it's very important, and it's one of the key things in cancer research. And this is the first time AI has developed a protein binder for this protein. It's quite a breakthrough. Cognitive computing is also used by health agencies to predict the spread of illness and also epidemics. It's also used in cybersecurity and fraud detection. And the way it works there is that it is really good at anomaly detection, which is detecting unusual behaviors. So it's able to detect an unusual behavior, say in a credit card purchase, that is unusual for whoever the credit card holder is, or in a computer system, anomalous behavior or unusual behavior that has the signature of a break-in attempt. Cognitive computing recently also solved 4 of the 6 problems in the International Math Olympiad. And what the International Math Olympiad is, it's a set of very difficult equations, 6 specially designed, very difficult math problems for pre-college math talent. A cognitive computing AI solved 4 of these 6 problems, and that would have given it a silver medal performance if it were a human being. And keep in mind that these are the least capable these systems will ever be, because they're always developing and becoming more and more powerful, literally by the day. So we are in for more and more capability and surprises, both good and bad, from the uses of cognitive computing. So that's cognitive computing. And cognitive computing, again, is computers imitating human thought and decision making. And they're able to take data from natural language processing and data they get from computer vision and other areas and make decisions based on that. A recent branch of AI related to cognitive computing that's gotten a lot of attention lately is generative artificial intelligence, or Gen AI. And that's products like ChatGPT or DALL-E or new applications that can even do videos. And the way it works is that the user goes in, types in a prompt, types in a description of what they want, then the AI just brings out whatever it is they're asking for, whether it's a picture, an image, or text in ChatGPT, answers that it generates, and it could be anything from a single sentence to a research paper. So now it's considered by some in the industry to be a form of cognitive computing, but there's a very key difference between true cognitive computing and generative AI, or Gen AI. And that is this. Cognitive computing is designed to analyze, research, and come up with the best answer, the most accurate answer possible. That's cognitive computing. Generative AI is not designed to do that. What it's designed to do is to look at the prompts that a user types in, or the questions that a user types in, and then come up with text or an image or whatever. In ChatGPT's case, it's text that looks reasonable as a match to the user's query, prompt, or question. ChatGPT and those sort of chatbots don't do research. They don't do any searching. They don't do any analysis. What they're doing is that they're looking for word combinations that seem to match what the user is asking for. without any regard to whether the answer is right or wrong. And this can lead to pretty disastrous consequences. For instance, a lawyer, his name was Stephen Schwartz, this lawyer went to court with court documents and prepared cases. He went to court with a court filing that he basically got from ChatGPT. He filed it, and it turned out the whole thing was fake. And even the sources that ChatGPT had assured him were correct, those were fake sources too. I'll explain later how these programs are designed, how these generative AI programs are designed, and why they produce those types of results. But anything that you get from ChatGPT or from the Google AI Bard, right now, Google, if you do searches on Google, they have an AI summary section at the top. Then they'll summarize whatever the answer is to your query. Anything like that, make sure you double check. Don't trust them. Use them as maybe a guide or a starting point, but double check everything they're saying with actual sources in your search results below, especially if you're doing anything important, or if you're going to post something or write something, anything important. So these three areas, natural language processing, computer vision, and cognitive computing, are one group of what AI does, and it's the part of artificial intelligence that we see. The other three areas are the part of artificial intelligence that we don't see, and those are the areas covering how artificial intelligence is built. The first is neural networks, and a neural network is really just a networking program. It's just like your home network or your network at work, networking all the different employees together. Your ISP networks a lot of users together with computers. All of it's networking, and that is really what a neural network is. The difference is that a neural network is designed to imitate the structure and function of a human brain, and we're going to get a lot more into that in a few minutes. The next area is machine learning. And machine learning is when you can tell a computer, an AI program specifically, different data, like what is a customer, what is a sale, what is a product, what is a product description. And then the AI can figure out what's going on with customers and sales and what new recommendations to make to customers to help enhance sales for the company and to make the customer happy. So that's machine learning. The final area is the real power of AI as we know it today. It's the secret sauce, the artificial intelligence superpower, and that is called deep learning. Deep learning is a subset of machine learning. And with deep learning, whereas with machine learning, you have to tell the AI what a customer is, what the product description is. When you have new products, you have to add them in. It takes some human maintenance to do that. With deep learning, you just feed the AI this information, and it will figure out on its own what is a customer, what is a sale, what is a product, what are product descriptions, what are photographs. And it will figure all that out on its own. It will make decisions on its own, and will often be able to make associations and notice things about the data that human beings can't, or that human beings normally wouldn't. The most famous case of this is with an Amazon situation, where Amazon was notifying this dad about pregnancy products. So it turned out that his daughter was pregnant. And what happened was that the AI had figured out that the daughter was making searches related to pregnancy on the Amazon website. And then it figured out that the dad and daughter were related, and it figured that the dad would probably be interested in these products as well. So that is deep learning, and though it can cause some questionable situations like the one we just described, it can also do some very powerful things that we'll get into later, including helping a robot dog to master complex activities that it wasn't even programmed to do. So again, all of these areas are AI, and there are many, many things inside of each area that are way disparate and different from one another, but they all roll up into these 6 different areas. Now, AI programs like ChatGPT or the driverless taxis or our robot dog actually use multiple of these different areas together. So again, what AI isn't, it's not just one thing, it's many, many different things that group into 6 rough areas. What AI is, it's computers trying to imitate the way that human brains think and learn. So in order to understand how AI works under the covers, how it does what it does, we have to understand how the human brain works. Now, our brains are organized in roughly 2 different areas. There are areas like vision and decision-making and language processing that we think about and do. And then there are other things like breathing, heartbeat, reflexes that we don't think about, we just do. So these 6 areas of artificial intelligence that we just talked about map roughly to corresponding areas of the brain. So the things that we can see, like the computer vision, cognitive computing, natural language processing, those map roughly to the higher areas of the brain. Whereas the back-end areas, neural networks, machine learning, deep learning, the structure that makes everything run, that maps roughly to the lower areas of the brain that are just our reflex and our automatic or autonomic functions that just work. And those are the parts that we don't see, just like with AI. Now, this entire giant brain structure works on one small component. It is called the cell, or the neuron, the brain cell. So our entire brain is made up, of course, of neurons, and each brain neuron has 3 parts. The first part is where it gets information and instructions from other cells. These are called dendrites. The second area is where the brain cell actually processes all this information. It decides what to listen to, what to do with that information from the other cells, and that's called the soma, or the nuclear part of the cell. And the third part of the cell, after deciding what to do and processing the instructions, the brain cell gives instruction to other cells, and this part of the cell is called the axon. So those are the three different parts of the cell. They're the receivers, the processors, and then the instructors. And now, a real neuron is a lot more complex than this, and it has over 5,000 dendrites and axons in every single cell. Psalm 39:14 says, "I will praise you, Lord, for I am fearfully and wonderfully made." And that is absolutely true of our brain cells and the rest of our body, but especially our brain cells. And in reality, our brain cells constitute an actual living neural network, a network of cells that all of the cells talk to each other, different parts of the brain talk to each other, and that's how we get everything done that we do as people, including our thought, processing, and reasoning functions, which artificial intelligence is trying to imitate. So artificial intelligence works basically the same way. So within this larger artificial intelligence program, which is sort of like an artificial imitation brain, there are these small pieces that process different pieces of information. And so looking back at our cell, when our robot dog is trying to learn how to walk, it will go through a process similar, its AI program will go through a process similar to what our brains go through. And that is, let's go back to our neuron. Our neuron is receiving information from other cells. So the AI program is receiving information as well. And it may say for 1 foot of the dog, it'll receive information about the height, about the change in height, how fast it's rising or lowering, and then the speed at which that foot is going. And that corresponds to the dendrites in a human brain cell. So then it'll go ahead and process it, and it'll figure out which of these inputs to listen to and what to do with them. And that decision-making process, that decision-making area of the program, corresponds to the soma, or the decision-making part of our human cell. Then what it does is figure out what it wants to do, and it will direct the foot to do something. So it will tell its foot where to go. It'll decide where to place the foot. So it's the same type of process, vastly simplified, but it's the same type of process that our own brain cells go through when we're trying to decide to do something. Well, it turns out that just like the human neuron, like our brain cells are a lot more complicated than that simple diagram that we looked at. Actual AI programs are a lot more complex than the simple diagram that we use to explain them. And they're more complex in two ways. One is the sheer complexity of the programming itself. So we looked at a small individual decision for one leg. We had the height, the speed, and the change in height of one leg. In real life, an animal simulation would have inputs from all 4 legs. It would have additional inputs like vision data, sensor data, motion detectors, internal information from its actuators, and an actuator is the actual sort of like the muscles in a robot that make the robot's legs and other parts move, and additional information, and it would be processing all of that input. Another thing is that the decision portion isn't going to be just one little cell to make one decision like the one we looked at to simplify things to explain how it works. What will actually happen is that there will be many decisions, multiple decisions, and actually multiple layers of decisions that will have to be done, different stages of decision making before the actual output goes and the commands go to the different feet of the robot, dog in this case, to actually move. So that's one thing, is that this how complex the programming is. And by the way, when there's multiple layers of decision making like that and multiple decision steps, that's what's called deep learning. If there's just one layer of decision, even if it's a complex one, that's machine learning. So that's how those two are related. So that's the programming part of it. The second part that makes it more complex is the sheer amount of computing power that's required to create the program that makes the robot dog work. AI programs, at least the bigger ones like ChatGPT, like the Microsoft Bing, like the Google Assistant, and Amazon Alexa, and those sorts of programs, and also generation for complex robots, dogs or humanoids, or whatever kind of robots, those types of programs run on giant computer banks. And these can be the size of rooms, the size of floors of buildings, and the size of entire buildings. They're titanic computers, all networking connected, creating thousands and hundreds of thousands of different mini programs that function like neurons, these little decision-making programs, all working together, networked together in a single large program. Creating that requires huge amounts of information. It's called training data, and what it does is it's data that helps the computer, the AI program, figure out, or gives it the information that it needs to kind of figure out what the different parts are, what it's supposed to be doing, and how to use the different information it has to achieve the goal. That's called training a model, and a model is a program that has a method or a way of how to do things, an approach of how to do things. Training these models for large models can take huge computer systems like this 6 months, a year and a half, even a couple of years to create these really sophisticated programs that power large AI systems. And the result of that is that after all that time, with all that computing power and all that data, tons and tons and tons of data. For a robot dog, it would be various data like anatomy data or data on how different parts of the robot move or the materials that it's used, how to coordinate the vision with the motion sensors and other information. All of that takes a long, long time, but it's run on these giant computers and then it's distilled down into a small program that can be loaded onto the computer that's on the robot dog. So it's a lot more complicated than the simple diagram that we have, but that simple diagram shows at the core how it really works. It's huge as systems as these are. And there's actually a third way that it's more complex, and that is that there are a great number of different ways to build and design these programs to achieve similar or the same goals. So there's choices that the AI programs have to make and the designers have to make in terms of the different information they have, the way they structure the program to make it work. And that's why, as I explained in the beginning, AI is not just one thing. It's a wide variety of things that fall into a number of different areas, but they all have some of the same ideas around them, the same ideas incorporated in them, rather, to be able to accomplish goals, a wide variety of different tasks using artificial intelligence. Okay, so now we know how the robot dog can walk, but how does the robot dog go beyond that and start doing things like playing soccer that it wasn't even programmed to do? In order to do that, we have to understand how the different parts of AI work together and how these different areas that we all call AI as a whole, but these different types of artificial intelligence work together in a complex system like a driverless car or a robot dog. We also need to know some more things about how AI works. We also need to know some more things about some of the benefits of AI, how it's going to impact your job and the rest of your life, and then also some of the dangers, some of the flaws in AI that they don't really talk about much, that the AI companies don't really talk about very much. And also, as these things develop, you really should at least get to know about the gospel of Jesus Christ, because some of these things that are coming are exciting, but others are really disturbing. And this is not conspiracy theories. Some of the top experts and owners of companies and leaders in the field of AI are genuinely worried and concerned about these things. I'll explain some of these things in a lot more detail when we discuss the questions that AI is raising right now about the very nature of humanity and about our future or even our survival as a species, and some of the things that have already happened, like chatbots threatening people. Or one AI actually tried to get a journalist to leave his wife for it. Leave your wife and come with me, said the AI chatbot. How on earth did that happen? For some of the things that are coming, we're all going to need some hope. There's a link above, so please at least take a look, even if you're not a believer. Well, I'll explain all of that and more in the next video. See you there.